Okay guys, so 1.5 we're going to look at lipids. We talked about carbohydrates in previous videos, move on to this now. So lipids were more commonly known as fats prior to starting this. So there's two types. There are phospholipids, which are present in the membrane. Talk more about those at a later date. And we also have triglycerides. So triglycerides are what we would more commonly refer to as fats or lipids. They're the stuff that are present in our fat tissue or our adipose tissue underneath the surface of our skin. So we need fats, if you remember from like GCSE, we need them for energy storage, and also really for insulation, particularly around our visceral organs, our important internal organs. So a triglyceride is made just like a carbohydrate of carbon, hydrogen and oxygen, but in different ratios or proportions to a carbohydrate. So we take a few of these molecules, but firstly we're going to kind of like think about some of these properties. So fundamentally, a lipid is insoluble in water, and that's going to become important later when we look at membranes and phospholipids. So if it's insoluble in water, generally these lipids will be soluble or will dissolve and associate with other solvents like alcohols. Okay? So that will become important when we look at the food test in a second. So if we look at the molecule itself, in a triglyceride, we've got glycerol here, glycerol head. So a glycerol is an example of an alcohol, anything ending in ol. And we've got 3 fatty acids. That's where the word tri comes from in triglyceride. Okay? There's fatty acid 1, fatty acid 2. But the link that forms those two together is called an ester link. Okay? Ester bond. So the OH and an OH on the fatty acid here form a molecule of water in a condensation reaction. So that forms water in each one. Let's make a bit of room here. So if we have 3 condensation reactions taking place between the fatty acids and the glycerol molecule in the center, that's going to mean we have 3 molecules of water. So we've got one here, one water here, and one water here. Okay? So fundamentally, that's how we form a lipid, and vice versa. If we wanted to split the triglyceride, we'd put the water in a hydrolysis reaction, and that would break it up. Okay, so there's something else we've got to understand, a bit more detail about these things, these fatty acid tails. Okay, these fatty acid tails. So what we're going to have a think about is a term called saturation. Okay. So if a tail is saturated or unsaturated, and I'm going as far as you need to with the chemistry knowledge here, primarily because mine's not very good. But if we take carbons here, if a carbon chain is saturated with hydrogen, that means at every possible point where there can be a hydrogen attached to a carbon, there is one. So these would all be hydrogens here. So that means there are no double bonds at any point within the molecule. So I got one there. So this fatty acid chain, this carbon chain, which is what a fatty acid chain is made of, is fully saturated with hydrogen. Now if we had an unsaturated chain, the carbon chain would have some hydrogens, but then it would also have present on it double bonds. So we get this here and this here. Now what this creates, so don't think like brilliantly shown in the textbook there, are kinks. So we've got hydrogens where there is a bond available. Each carbon would have 4 bonds attached to it. So here we get some hydrogens. But as a result of these double bonds, here and here, we have a kink in a tail. So these ones here, the fatty acid tails, are all going to be nice and straight. But here, the tail itself is going to look more like that. And that's going to become important when we get on to membrane structure. So membranes are made of another type of lipid altogether, triglyceride, but this is called a phospholipid. And a phospholipid makes up the vast majority of the membrane, which we'll look at in another video. So here's the phospholipid here, the heads, the tails line up next to each other, and where they do, if the trains are nice and straight, we get a nice line up, a nice arrangement, and that prevents things moving through. Explain more about this later. But if we have a kinked arrangement, that leads to a less sort of stable lineup, and there's more kind of pores in between. So that's where saturation comes in. The phospholipid itself has two fatty acids, which is different to the triglyceride. And instead of having a third bond there, third fatty acid, it has a phosphate, which is where the term phospholipid comes from. And that creates a polar nature in the triglyceride. So the head itself, where the phosphate is positive in nature, the tail is negative. And also, its attraction or its affinity to water has changed. So the head itself is hydrophilic, beg your pardon. Hydrophilic means that it likes water, it's attracted to it, not bothered by it. But the tail itself is hydrophobic. And that means like you've got a phobia or something, you don't like it. Hydro means water. So the tails don't like water, the heads don't mind water. And that creates something called a bilayer in the membranes. Again, we'll talk about that more when we look at membrane structure. So that's phospholipids and triglycerides, which are the two types. Now, how do we test for them? Well, we're going to use ethanol. So what we do first is we take the sample, we dissolve it in water after we've mashed it up, and then once we've mashed it up in water, we drop it into ethanol. And then having dropped it in ethanol, if we get a white precipitate, that indicates a positive result and lipids are present. So that'll be the same for any type of lipid, whatever fat you're looking at. So you need to know how to test for these, as well as carbohydrates and proteins.